Hey guys, welcome to question 2 for the 2018 level 2 calculus exam. Okay, I know it's been a while since I posted question 1, but we're just gonna get straight into it. Watch question 1 first if you haven't watched question 1. The graph of a function y equals to f of x is shown in the axis below. Sketch the graph of the gradient function y equals to f dash of x on the axis below. Both sets of axes at the same scale. Okay, first thing you do, you want to find the equation of this parabola. Okay, so as you can see, this is the x-intercept is -3 and here is 1. Okay, so y equals to a x plus 3 x minus 1. Okay, substitute a random point in, so we're going to say -1 and 1. Sorry, -1 and 8. Okay, so 8 equals to a -1 plus 3 -1 minus 1. 8 equals to a 2 -2, so 8 equals to -4a, a equals to -2. Okay, so now we have y equals to 2x, or -2 x plus 3 x minus 1. Okay, so now we're going to expand, so y equals to -2x squared plus 2x minus 3. Y equals to -2x squared minus 4x plus 6. Okay, so now we're going to say f dash of x, okay, equals to -2 times 2 is -4. Take the power down by 1, so -4x minus 4. You just get rid of the x. That should be your linear equation. Okay, so now we're gonna plot this. Okay, so when x equals to 0, it's -4. 1, 2, 3, 4. When x is -1, f of x is 0. So yep. And just substitute a few more points. We say 1. If we substitute x equals 1, so -4 minus 4 is -8. Okay, we'll substitute -2, that will give us 4. 2, 3, 4. Yeah, we have our general line here. Okay, so we're just gonna draw a line right through these points. And yeah. Yeah. And there's our graph. Okay. And getting all the way here to drawing the graph, okay, that'll give you an achieved grade. Okay, this is an achieved question. Alright, next question. A skyrocket is projected into the air so that t seconds after it is launched, its height, h meters above the ground, is given by h of t equals to 39.2t minus 4.9t squared. What is the maximum height that the skyrocket will reach? Okay. Alright, so the first thing you know, okay. Okay, so it says the height, okay, is given height after a certain amount of time is given by 39.t minus 4.9t squared. Okay, so now we're gonna differentiate to find the gradient function. Okay, so we're gonna say h dash of t equals to 32.9 minus I can't do basic math. Minus 9.8t. Okay, so now you know I'm gonna draw the parabola here. Okay, so it's gonna look something like this. So the original graph will look something like this. It'll be like for example, a parabola like this, right? So now we have h of t. Okay, we're gonna substitute the gradient function equals to 0, so we'll find the turning point. Okay, and the turning point is where our maximum height will be. Okay, so we're gonna say 0 equals to 39.2 minus 9.8t. Okay, so therefore we can figure out that t equals to 4. Let me just double check that actually. Yeah, t equals to 4. And then we're going to substitute t equals to 4 in the h of t to find our height. Okay, so we're going to say h of 4 equals to 39.2 times 4 minus 4.94 squared. Okay, and we plug this into our calculator. That will give us height equals to 78.4. Oh, no, that's a bad height. 78.4 meters. Okay, and getting all the way to 78.4 meters and t equals to 4, that will give you a merit grade. Okay, in terms of getting it achieved, you're getting the derivative and making it equal to 0. Okay, so getting it up to here, that's an achieved grade. Alright, moving along. Adam is operating his drone. It is moving in a straight line, and t seconds after passing his tree, its acceleration, a meters per second, is given by a of t equals to 6 minus 12t. 2 seconds after the drone passed the t, its velocity was 20 meters per second. How far was the drone from the t when the velocity was 20 meters per second, okay? So basically, okay, so you have acceleration, okay, and one thing I want you to remember, okay, is if you have a of t, okay, and you integrate it, okay, if you integrate it, that'll become v of t, okay, and if you integrate it again, it'll become d of t, okay, and so you'll start at acceleration, okay, acceleration integrates to velocity, and velocity integrates to distance, okay, vice versa, distance differentiates to v of t, and v of t differentiates to a of t, okay, so I want to get that straight, okay, so so it's moving in a straight line, t seconds after passing tree, it's acceleration, given by, okay, so 2 seconds after the drone passed the tree, its velocity was 20 meters per second. So now we're going to integrate to find the v of t, okay, integrating this, okay, so v of t equals to 6t, okay, minus 12t squared divided by 2, okay, so you increase the power by 1, and then you divide by the power, okay, so v of t equals to 6t minus 6t squared, okay. So basically, we still have a plus c, because when we integrate, okay, remember when we differentiate, for example, we differentiate 2x squared plus 7, okay, that will become 4x, and we'll just get rid of the plus 7, okay. So when we integrate, okay, we have to remember that there's always a plus c that was ignored when we differentiated, okay. So you have the plus c that we don't know, and we need to find out what that c value is, okay. But that's perfect, because it tells us 2 seconds after the drone passes a tree, its velocity was 20 meters per second, okay. So we can say that 20 equals to, substitute t equals to 2, so 6 times 2 minus 6, 2 squared plus c. 20 equals to 12 minus 4, 2 squared is 4 minus 24, sorry, you have a minus there, minus 24 plus c equals to 20, okay. Therefore, c equals to 32, so therefore v of t equals to 6t not plus, minus 6t squared plus 32, okay. So now we need to find out how far from the drone, from the t when the velocity was 20 meters per second. So you know that 2 seconds after the drone passed the tree, the velocity was 20 meters per second, okay. So now we're going to integrate from velocity to distance, okay, and we're going to substitute t equals to 2, and we're gonna find the distance, okay. So we're going to say d of t is equal to 6t squared divided by 2 minus 6t cubed divided by 3 plus 32t plus c, okay. We don't know what the c value is, okay. So d of t equals to 3t squared minus 2t cubed plus 32t plus c, okay. Okay, but you know, okay, so what the question tells you, it is moving in a straight line, and t seconds after passing a tree, its acceleration is, so it's the distance is recorded after it's passing a tree, okay. So therefore, when time equals to 0, so when no time has passed, the distance from the tree is 0, because the drone starts from the tree, okay. So the drone starts from the tree, okay. So when the drone hasn't started, it's at the tree, so distance from the tree is 0, okay. So we know when t equals to 0, d equals to 0, okay? And if you just plug this in, just for example, so 3 0 squared, as you can see, any 0 to the power of anything is 0, so this will just end up as c equals to 0, okay? So now you have d of t equals to 3t squared minus 2t cubed plus 32t. Okay, so now we're going to substitute t equals to 2 and we'll find the distance from the tree after 2 seconds, okay? The reason we're substituting t equals to 2 is because that's when the velocity is 20 meters per second, is what the question tells us, okay? So we're going to say d of 2 equals to 3, 2 squared minus 2, 2 cubed plus 32 multiplied by 2. Okay, if we plug this into a calculator, okay, it should give you d equals to plus 64. You'll get d equals to 60 meters. Oops. You'll get d equals to 60 meters, okay? And that should be your final answer here, okay? So when t equals to 2, s equals to so when, or not s but d, okay? So when t equals to 2, d equals to 60 meters, okay? And that will give you the excellence grade all the way down here. That'll get you the excellence grade when you found t equals to 2 and d equals to 60 meters, okay? That'll get you an excellence grade. To get a merit grade, okay, you're looking at the distance equation found, okay? So you're getting d of t correct, okay? So d of t is here, so getting correct d of t, so 3t squared minus 2t cubed plus 32t, that'll get you a merit grade. In terms of getting an achieved grade, you're finding the velocity equation, okay? So if you find v of t equals to 6t minus 6t squared plus 32, you'll get an achieved. Hey guys, welcome back. Sorry the video got cut off, but we're just gonna move on to the next question, okay? Sorry about that. The graph of the function y equals to x cubed minus 6x squared plus kx minus 5 has a turning point at x equals to 3. Use calculus methods to find the coordinates of both turning points. Determine the nature of each turning point, justifying your answer, okay? Okay, so the first thing you want to do here is you want to differentiate to find the gradient function, okay? So we're going to say f dash of x equals to 3x squared minus 12x, okay? So you just basically just multiplying the front number by the power and taking the power down by 1, okay? So that's all you're doing, plus k, okay? So you know that when x equals to 3, turning point, so you know at the turning point the gradient is 0, right? So at the turning point the gradient is 0, so therefore when in the gradient function, when x equals to 3, then f of x will equal to 0. So by using this we can find where our k value is, okay? So we can say 0 equals to 3 minus 12 times 3 plus k. 0 equals to 3, 9 minus 36 plus k. 0 equals to 27 minus 36 plus k. Therefore, k equals to 9, okay? Okay, so now we can rewrite our f dash of x, okay? We can write f dash of x equals to 3x squared minus 12x plus 9, okay? Alright, so now we can find our turning points, okay? So our turning points is when x equals to 0, okay? So 0 equals to 3x squared minus 12x plus 9. 0 equals to 3x squared minus 4x plus 3. So 0 equals to 3x minus 3 x minus 1, okay? So therefore our turning points, okay? So our turning points is x equals to 3 and x equals to 1, okay? So now we have our turning points, okay? So use calculus methods to find the coordinates of both turning points, okay? So we're going to substitute x equals to 3 and x equals to 1 into the original function in order to find the coordinates of this turning points, okay? So if we're going to do x equals to 3 first, we'll say y equals to 3 cubed minus 6 times 3 squared plus, you know, k equals to 9, so times 9 times 3 minus 5, okay? So y equals to 9 minus what am I doing? Minus 9 times 6 is 54, plus 27 minus 5. Plug this into a calculator, okay? That should give you 9 minus 54 plus 27 minus 5. That gives you negative. Wait, what? Did I screw something up? I think I did. How'd you get? Sorry guys, just hold up for a second. I think I might have done some calculation mistakes here. Wait, hold up. That is weird. How'd you get negative 5? Oh, 3 cubed is 27. That's the one. That's the one I was being stupid on. Sorry, guys. 3 squared is 27, not 9. Oh, that's such a basic mistake. Sorry, guys. I held you up for like 1 minute for a stupid mistake. That is really stupid. Far out. Yeah, now we can get our... Now y is negative 5. So y equals to negative 5. And now we'll substitute x equals to 1. Okay, so we'll say y equals to 1 cubed minus 6 times 1 squared plus 9 minus 5. Y equals to 1 minus 1 squared is 1 minus 6 plus 9 minus 5. Plug into our calculator. Should get negative 5 here, negative 5, 4, negative 1. Okay, so y equals to negative 1. Okay, so our coordinates are 3, negative 5, and negative 1, 1. Okay, not negative 1, it's the other way around. So 1, negative 1. 1, negative 1, okay? So, but now we're not done yet. We need to show the nature of our turning points, okay? So we have to justify our answer saying what turning points are, okay? So we're going to say f double dash of x, okay? So we're going to differentiate again, okay? We'll hit f double dash of x equals to, we'll say 6x. Yeah, we're just differentiating this equation here, okay? So 6x minus 12. Okay, we're going to substitute 3 into the equation. So f double dash of 3 equals to 18 minus 12. So it's equals to 6. 6 is positive, okay? Therefore, minimum turning point, okay? So what do I mean by a minimum turning point, okay? You must think, oh, what is a minimum turning point? So if I just draw a mini cubic here, okay? So let's just say this is just a example cubic, okay? So as you can see here, there's the maximum here, okay? So it's when the y value is the highest, and there's a minimum turning point here. It's when the y value is the lowest, okay? So that's what they mean when I say minimum and maximum turning points, okay? So 6 is a positive number, and therefore it's a minimum turning point, okay? And if we substitute x equals to 1, then we'll definitely get a negative number, okay? Just to show, we'll get a negative number, so 6 minus 12 equals to negative 6. Negative, therefore, maximum turning point. Okay? So that's our way to justify our, so therefore we can say, 1, negative 1 is a maximum. And we can say 3, negative 5 is a minimum. Okay, and getting all the way up to here at the bottom here with the justification, okay, all the justification, all the working from behind, that'll get you the excellence grade, okay. To get the merit grade, okay, to get the merit grade, you're looking at finding the value for k, and you're finding the x values of the turning points, okay. So you're finding x equals to 3 and x equals to 1, okay, and you're also finding k equals to 9, okay. So both of these will get you a merit grade, okay. And to get an achieved grade, you're looking at derivatives set to 0, okay. So basically putting just getting this equation here, that'll get you an achieved. Alright, moving along. Oh, sorry, I better get rid of some of this. Sorry, I forgot to delete some of this stuff. Forgive me guys, forgive me. Okay. The gradient function of a curve is given by dy over dx. That's basically f dash of x equals to negative 5x over 4 plus 6. The curve passes through 1, 7. Find the equation for y, okay? So first we're going to integrate, okay? So we're going to say y equals to negative 5x to the power 5 divided by 5 plus 6x plus c, okay? So we're going to say y equals to negative x to the power 5 plus 6x, okay, plus c. So therefore, when x equals to 1, y equals to 7, okay, so 7 equals to negative 1 to the power 5 plus 6 plus c. 7 equals to negative 1 plus 6 plus c. 7 equals to 5 plus c. C equals to 2. Okay, so therefore our equation is y equals to negative x to the power 5 plus 6x plus 2. And getting all the way down to here, that'll get you a achieved grade. Alright, suppose that at the start of a particular day, 1,000 people are trading in the market, and in the t days after the start of that day, the number of traders n can be multiplied by n of t equals to 1,000 plus 400t plus 100t squared. How many days will it take for the rate of change for the number of traders to be 14,400 per day, okay? Okay, so basically we're gonna find the n dash of t, okay? So we're gonna say that the gradient equals, we're gonna find the gradient function, and then we're gonna make the gradient equal to 14,400, and we're gonna find what time value is that, okay? So we're gonna say n dash of t equals to 1,000 will be gone, okay? So we're gonna say 400 plus 200t, okay? And 14,400 equals to 400 plus 200t. 14,000 equals to 200t. Therefore, t equals to 70, okay? And it's at the start of the day, so it's in days, okay? So it's 70 days, okay? And getting all the way up to here, 70 days will get you an achieved grade, okay? So 2 easy achieved questions. Alright, next question. Next question, let me erase it first. Okay. A school is selling tickets for its drama production. The revenue $R from selling tickets for a price of $P each can be multiplied by the function R of P equals to 40P multiplied by 29 minus 2P. Use calculus to find the maximum possible revenue, okay, using this model, okay. So basically we're just going to find the gradient function, okay, and we're going to make the gradient equal to 0 because it's the maximum possible revenue, okay. So we're going to make, because at the turning point, at the maximum turning point, the gradient will be 0, and therefore we make the gradient function equal to 0, okay. So we say R dash of P equals to, actually we should expand first, honestly. That would be a good idea. R of P equals to 40P multiplied by 29, what is that? 40 multiplied by 29. 1,160 minus 80p squared, okay? So now we can say R dash of P equals to 1,160 minus 160p. And we're going to substitute the gradient function equals to 0. So we'll say 0 equals to 1,160 minus 160p, okay? So therefore, we should be getting our P equals to 7.25. P equals to $7.25 $6. Okay, so the price of one ticket equals to $7.25 for the maximum revenue. Okay, and use calculator to find the maximum possible revenue. So we're going to substitute P equals to $7.25 into the original equation. Okay, I should say RP equals to 160 times 7.25 minus 87.25 whole squared. Okay, so we're gonna plug this into our calculator. Minus 80 times 7.25. No, not 700. Oh god, sorry guys. Just wait a second. Wow. That should give you R of P. That should give you the R of 7.2. R of 7.25, and if you plug it into a calculator, you should get equals to $4,205. So $4,205 is the most amount of money that they can collect by doing the drama production by selling tickets at $7.25 each. Okay, so getting all the way down to here, $4,205 dollars, that will get you a merit grade here. Okay. All right, next question. Just let me plug my iPad in before it goes dead on me. Just sorry about that. Okay, so let me delete this. Okay, a tangent of a graph of the function y equals to negative a third of x squared plus kx plus 4 at a certain point P has a gradient of negative 7 and intersects the gradient again at negative 664. Use calculus to find the coordinates of point P. Okay, so a tangent to a graph, okay, it has a gradient of negative 7 and it intersects the graph again at negative 664. Okay, so basically for this question, okay, we're going to find we need to find what the k value is first. Okay, so if we find what the k value is first, okay, so right, okay, so it's going to intersect the graph again at negative 664. Sorry, I got a bit black out there. Okay, so therefore we can substitute negative 6 and 64 to find our k value. Okay, so we'll say 64 equals to negative 1 over 3, negative 6 to the power of 3, plus k multiplied by negative 6 plus 4. 64 equals to negative 1 over 3 times negative 216 plus negative 6k plus 4. So 64 equals to a third of 216, so 72 plus minus 6k plus 4. Okay, so we're going to say 68 equals to 72 plus 6k. Therefore 16, it's a 16, no it's not, it's no, it's 60, sorry, 60, that negative 4, sorry, so therefore negative 12 equals to 6k. Therefore what, how is k2? Oh yes, minus far out. What am I doing? It's minus 6k, so it's equals to. Sorry guys, I'm being so stupid. So k therefore equals to 2. Y equals to 1/3, negative 1/3 of x cubed plus 2x plus 4. Okay. At a certain point, P has a gradient of negative 7 and intersects the graph again. Okay. So therefore, we're gonna find the gradient function. Okay. So we're gonna say f dash of x equals to negative x squared plus 2. And because the gradient is negative 7, okay, we'll substitute negative 7 equals to negative x squared plus 2. Therefore, negative 9 equals to negative x squared. Therefore, 9 equals to x squared. So therefore, x equals to 3 or negative 3, okay? We have x equals to 3 or negative 3 here, okay? So we're gonna find okay, so we have 3 or negative 3, okay, but one of these solutions are not possible, okay. Sorry, just hold up. Okay, so now we have to we'll find the equation for our tangent. Okay, we'll say y equals to mx plus c. Okay, we know our gradient is negative 7, so y equals to negative 7x plus c. Okay, and we know that when x is negative 6, then y is 64, so 64 equals to 42 plus c equals to 22, so therefore y equals to negative 7x plus 22, okay, and they will intersect when these two are equal, okay, so negative 7x plus 22 is equal to our function, okay, it's equal to negative a third of x cubed, negative a third of x cubed plus kx plus 4, which is, we found that k is 2, so plus 2x plus 4. Then we'll solve this equation here, okay, so we'll say 0 equals to negative a third of x squared, x cubed plus 9x minus 18, okay, we plug this into our graphics calculator. So if I have graphics calculator, so we'll say a is negative 1 over 3. You have to go to the third degree, so you're gonna say negative 1 over 3. Our b value is 0, c value is 9, and negative 18. Okay, so we have our intersections. Okay, our intersections are at x equals to 3 or x equals to negative 6. Okay, so negative 6 is here, so negative 6, 64, and we also have x equals to 3. Okay, so now we prove that negative 3 isn't a real solution. Okay, so therefore x must be equal to 3. So now I have to find the coordinates of point P. Okay, so we just substitute. Okay, so we substitute that so therefore point P would what am I doing? Okay, so in our tangent equation, in case we'll say y equals to negative 7x plus 22, we'll say y equals to, substitute 3, so negative 21 plus 22, y equals to 1, so therefore the point of P is therefore 3, 1. Okay, so that should be your final answer. Okay, sorry about all that mess. Okay, sorry, I was blacking out like hell. Okay, sorry about that. So that should be your final answer here, and that'll get you an excellence grade. Okay. in terms of getting a merit grade, okay, you found your K value, and you have to find your derivative found, okay, so you found your K value, so K equals to 2. You'll find this x equals to 3 or negative 3, and oh yeah, that'll get you a merit grade, okay. To get you an achieved grade, okay, setting the derivative equals to -7, okay, so we're gonna say -7 equals to negative, yeah, that'll get you an achieved grade, okay. Alright, next question. Oh, that's it. Yeah, okay, so thank you guys for watching this video, okay. I'm sorry about that last question, okay. I was being a bit funky, a bit all over the place, okay. Sorry about that. I apologize. I won't be like that during the next video, okay. Apologize. So, but still, thank you for watching the video. If you like the video, please leave a thumbs up, okay. Stay tuned for the next video, okay. Thank you.